Okay, so multiplying, dividing integers. Let's take a look at a couple other things. We'll look at some word problems, how you can use this. But hopefully by now we understand when you are multiplying and dividing, same signs are going to be positive, different signs are always negative. So one of the videos that I posted, it was kind of some corny acting with some, different skits and whatever. But really had some good examples. That's why I put it up there. And it showed this triangle, which I'm going to show to you right now, that will help some of us to remember some of the rules. So again, positive times a positive is always positive. That's not a part of this situation. So, it's still true. Same sign is always positive. But when we're talking about this triangle here, right? So here's what it has. It says if you have a negative involved in your equation, when you're multiplying and dividing, again, it says only when you multiply and divide. If you have a negative as a part of your equation, whether you have one integer, your second integer, and your answer. Those are basically your three parts of your equation, right? So what we're going to hit here is, depending on what you have, the two integer signs that you're using in your question. The third is going to be the sign of your answer. So here's what I mean by that. If you have a positive times a negative. So for instance, 5 times a negative 3. A positive times a negative, your answer is going to be a negative. So it's the third part of that triangle, right? And in this case, it's a negative 15. So that's how you can kind of use that triangle. If the two parts, if you recognize and understand and find the two different parts of that triangle that are your signs of your integers, then the third part of that triangle is going to represent the sign of your answer. So for instance, again, if you have two negatives, a negative times a negative, negative 4 times negative 7, your answer is going to be a positive. 4 times 7 is 28. They're both negative. So my answer is actually a positive. And again, this is another visual down here. If you have a positive and a negative, your answer is going to be a negative. If you have a negative times a positive, your answer is going to be negative. And if you have a negative times a negative, your answer will be a positive. So maybe that's helpful for you. But this triangle idea that they had in there, I thought was really good. Might help some of us understand and use the rules a little bit better. So there's that. Now and again, it's the same as when you divide, okay? Your multiplication, division rules, all the same. This is actually out of the Course 2 book. So it's just, again, let's see, what page are we on here? 234 in the green book. But it's just giving you some examples of why this works. Again, there's the repeated repeated addition that is multiplication, and understanding what that is. If you have 4 negative 3s, as we have right there, right? 3 steps back plus 3 steps back plus 3 steps back and 3 more steps back, you end up a total of 12 steps behind where you started. So again, different signs, always going to be a negative. If you look down here, again, not anything that we haven't done yet. 9 times negative 2, again, back to back, that means multiply, all right? And again, probably one of the biggest mistakes with that is a lot of people try to think of that as 9 minus 2, but no, that is 9 times negative 2. If you look at B, negative 7 times 4. 7 times 4 is 28. Different signs, that is a negative 28. Okay. All right, now, same signs, as we've talked about, same signs, always positive. 2 times 6 is positive 12. Negative 10 times negative 6 is positive 60. So, again, hopefully we're at the point now that is nothing new, but let's get some more examples out of the book. Okay, so word problem wise, I know it's always one of our bugaboos here. So let's take a look. It says Tamara owns 100 shares of a certain stock. Suppose that stock drops by $3 per share. Write a multiplication expression to find the change in her investment and explain your answer. Okay, so for each one of those shares, it's going down by $3. So the drop for each share is represented with the integer -3. All right, now for each one of those shares, if there are a total of 100, all you have to do is multiply by 100. And we know that altogether, if it's $3 for each one of those that went down, we've lost a total of $300. So let's take a look at some more. Hopefully they're on the other side here. Here we go. All right. So the question says, Ethan burns 650 calories when he runs for 1 hour. Suppose that he runs for 5 hours in 1 week. And again, the hardest part when they don't give you an equation directly is understanding which operations that we have to use and how to build our equations. That's probably the one thing that we gotta get better at to make sure that we improve on all these other different types of standardized tests that we take. But building the questions ourselves, when they give it to us, hey, we're usually pretty good, we can get it. But when we got to build it ourselves, that's where we got to get some practice in. So in this case, 650 calories each hour, right? And if he runs for a total of 5 hours, and again, he's going to burn 650, 650, 650, 650, and 650 calories each one of those hours. So in order to set that up, again, you could add 5 650s, or you multiply 650 times 5. Now, since he's burning it, we can say that is a negative. That's how much he's going to lose. So if he's going to lose 650 calories for each of those 5 hours, you can multiply that. And again, a nice way to do this mentally is to distribute it, which means, again, you're going to split that 650. Even though you might not be good at your multiples of 650, that is okay. You don't have to be. As long as you're good at your multiples of 6 and your multiples of 5, you can do this in your head. All right, so here's how I do this in my head. I take that 5, and then I split that 650 into 650. Okay? You multiply each of those friends by 5, and again, in your head. Really, the only part that you got to worry about is multiplying 5 times the 6, which is 30, and then I know I'm going to throw 2 zeros on the back, so that's 3,000. And you multiply that 5 times the 50. 5 times 5, that's 25. I got 1 zero, I throw it on the back, so 3,000 plus 250 is 3,250 calories. Again, we have a loss of that amount, so that is a negative 3,250 calories. That's how much Ethan burns when he runs for a week. All right. One more here. Wave erosion causes a certain coastline to recede at a rate of 3 centimeters each year. 3 centimeters a year. This occurs uninterrupted for a period of 8 years. So after 8 years, they want to know how much has eroded, how much has it gone away. And again, if it's receded, it's gone down. We lose 3 centimeters every year. So that's a -3. And if you do that 8 different years, you multiply those two, and again, 3 times 8 is 24. 1 is a negative. That is a negative 24 centimeters. Pretty ugly. Let me go back. cm. There you go. Okay. Now let's jump over. And again, there's our rules. Don't forever forget. Multiplying, dividing, same signs positive, different signs negative. Let's do some of these IXL problems. And again, this is right where you guys are as well. Multiplying, dividing, integers. We'll just do a couple fraction problems up here. Okay. Negative divided by a positive, we know it's going to be a negative, and 24 divided by 6 is 4. You got 24 sodas. You give an even amount to 6 different people. Each of them will have 4 sodas. In this case, I mean, they're negative, but you get the idea. Negative times a negative is a positive. 1 times 9. 1 times any number is that number. 4 times negative 8 is a negative 32. Times negative 28 divided by positive 4. You know it's going to be a negative. 28 divided by 4. 7. Negative, negative. It's going to be a positive. 18. Again, you think of your triangle with that. I like that triangle. I've never even seen that before, but I liked it. 6 times negative 3. Negative 18. Again, the fraction bar means divide, people. So if you are scared of the fraction bar, which a lot of us are scared of fractions, top goes in, bottom goes out. All right? So how many 3s are there in 24 is what it's saying. And again, that's just a positive 8.